The next fashion, the next section is the first thing we're going to come out is fashion and robotics, analog to digital processes in apparel. And this actually features some of the top minds in this field today from Hong Kong RITA, the Research Institute of Textiles and Apparel, and the University of Arts Linz. The first person up is going to be doing this from video because it's very late here. It's going to be Catherine Chan, Director of Business Development at Hong Kong RITA, and she's going to start us off now.
Good morning, everyone. My name is Catherine Chan, Director of Business Development for HKRITA. I'm very honored and thank you, Janice, for the invitation to allow me to speak about our center and also some of our recent projects at the 3D Tech Fest 2023. So today's topic is fashion and robotics, and I'm going to talk about some digital processes in apparel today. Let me first by introducing some information about our center. We are a research center for textile and apparel, and we were established in 2006, funded by the Innovation and Technology Commission by the government of Hong Kong. And we are hosted by the Polytechnic University, and our vision is to be the leading center of excellence in research and development and technical transfer in fashion and textile industry. Our center has the three main research themes. All of our projects are covered under at least one of the following research themes: sustainability, industry advantage, and also social benefits. Regarding digitalization and automation, and also such as AI and IoTs, it is covered in actually all of these research themes. Whether it's sustainability, industry advantage, or social benefits, we also apply these kind of technologies in our projects. Let me start by discussing what kind of challenge we have in the industry recently. We all are aware of the issues in environmental problems and sustainability, circularity. These are the recent issues that we are dealing with as a whole in the industry, that different scientists and also companies have been looking for solutions to improve on these problems. And in the textile industry, because it's a long-term industry in manufacturing that have been existing for over decades, and a lot of the production technologies are actually quite old-fashioned, and they need to be upgraded significantly in order to improve on productivity and efficiency. So as you can see in the statistics, textile industry is actually among the lowest in applying robotics in manufacturing processes. So there's a lot of room to improve, and there's a lot of spaces that we can apply the automation, digitalization in our manufacturing processes. And also, there are also many constraints in the labor markets. We all know that garment industry is very labor intensive manufacturing, and therefore a lot of skilled labors it's required. However, the so-called skilled, it's actually practically quite low skilled requirements for the manufacturing processes. So nowadays, a lot of the labor force, they are looking for higher technologies or more efficient manufacturing environments. That's why for the garment manufacturing processes, which require relatively low skilled labor, that's this industry is forced to be placed at a lower developed areas that requires lower skilled labor, or the working environment it's not that attractive anymore. So there are growing constraints in the labor markets that it's more difficult for the employers to look for good quality workers for the production. So constraints in the labor market is also a challenge for us in the textile and apparel industry. So how can we resolve these kind of issues by using AI, digitalization, and automation? Of course, with the automation and these kind of IoT solution can help to digitalize supply chain management, which can improve on the efficiency and also accuracy. And there are also programs or applications that can help detecting defects and also poor quality during the production process that can help to reduce the production timing and also reduce the waste at the manufacturing processes. So hence that it could improve on the productivity. We can produce more products in less time. The digitalization can also give room to create new business models for new entities. For example, customization and also quicker supply chain that can be more attractive to the newer generation. And also, there are programs that using AI to identify new design trends or even help to create design ideas for the fashion world that can give more varieties or more design that caters to the market needs. And so all put together, in the end, we can help to reduce time and also material use and wastage. That can give us a lot of more opportunities in improving on our businesses. Today, I'd like to share with all of you on 2 recent projects that we have done on digital-related topics. First of all is the smart garment sorting system for recycling. This is a project that we have very honored to have won the gold medal at the 40th International Exhibition of Inventions of Geneva this year. This is a sorting system that is designed using robotic arms and also hyperspectrum cameras to help identify disposed or recycled post-consumer garments. Imagine a pile of post-consumer garments that is collected in the community by using this smart garment sorting system with just the robotic arms and also a conveyor belt. Then we can pick up the post-consumer garments and have the hyperspectrum camera to identify different garment types, such as whether it's a shirt, whether it's a trousers, or jackets or scarf, this kind of different garment type in a very short period of time. And then it can also identify the fabric construction, whether it is a knit construction or a tight woven, a loose woven, or non-woven fabric. And also a more common classifications, including the fabric composition as well as color, can also be identified. All these classifications can be identified in a very short period of time. Each one, most of them can be identified in less than 1 second, around 0.2 seconds, to identify different categories, and the accuracy can be achieved by over 90%. So this helps on the efficiency and also the reduction of manual labor and the circularity of post-consumer garments, as we are all concerned about recycling very recently, that how we can improve on the efficiency in the recycling. The accuracy is very important because by identifying the accurate fabric composition, color, it can help to reduce the process time in the following steps. The next project I'm going to share about is the compact electro-adhesive gripper for fabric handling. This is also a project that went to Geneva, which we've won the gold medal with congratulations of the jury. This is a automation system that can be applied in garment manufacturing. Nowadays, there are different grippers to pick up fabric panels after the fabric cutting in the manufacturing processes. However, our project gives the flexibility on size and shape of the cut panels, and then it would also avoid the problems that the current solutions might apply. For example, that leaves some adhesive on the cut panel that might create wrinkles during the pickup processes, and also if the fabric is placed not flat enough, then it would not be able to be picked up. So all these issues could be avoided by using our system, because our system use a robotic arms and with a roller that can pick up fabric by electroadhesion force. So this can help in the efficiency in the manufacturing process, as well as the timing on the manufacturing. Thank you for listening to my presentations today, and you can reach us by these platforms and touch points. Have a good day.
Hi, everyone. So just a full disclosure, okay? I'm actually a board member of HKRITA. Those are the two that actually I was talking to Catherine about that was really interesting, the reason why they're interesting, okay? You always hear about AI and you don't quite realize that actually sometimes AI is actually hidden in a lot of things. And in that sorting aspect, just think about if a human has to go through that mound of clothes that you saw from the start that we actually, part of kind of my talk earlier, that National Geographic mound of clothing that was thrown in. If we could get something to pick it up, understand what, if it's a cotton polyester, and put it into a mechanical separator, we would be able to get that yarn back. The other thing that's very difficult is this. You see, we have fingers. Fingers can grip something really, one ply, really easily. But a robot arm, that has been the one single thing that actually has been stopping us from doing that kind of stuff. So all this is the geekdom of stuff that kind of we're interested in. But we have more geekdom for you, because I'm very happy to welcome Christiane Luible, Professor of Fashion and Technology from the University of Art Linz, to discuss some of the work she has been doing with Johannes Braumann, Professor of Creative Robotics, exploring how robotics can transform fashion processes through 3D manipulation of real garments. Christiane, welcome.
Hi. Thanks for inviting me. I can share the presentation, right?
Yep, go ahead.
All right. Yeah. Can you see the presentation?
Christiane, yes, we can, but it is not in presentation mode. I'm going to go ahead and play Johannes's video and we can figure this out. Okay. Would you like to introduce it?
First of all, thank you, TechFest, for giving us the opportunity to present our research here in this awesome format, and for allowing me to present it in a recorded format. In the Fashion Robotics project, my responsibility as head of creative robotics lies in the robotics aspect. In the field of robotics, we work a lot with both collaborative robots, but also with the large-scale robotic arms that you know from manufacturing. However, my actual background is coming from architecture and design. But when we started working with robots, we very quickly realized that the programming methods are not flexible enough for us, that we can really go into individualization and mass customization. So based on a visual programming environment, we started developing our own interfaces and processes so that we could really incorporate the customization aspect in robotic production. The result here was a software that's called KUKA PLC that is now actually really quite widely used, not only in academia, but also in high-end startups and companies where the goal is individualization. Like, for example, here we have a company doing individualized prostheses for people who have lost limbs. Or here we have a company called Relativity Space actually 3D printing entire rockets out of metal. In both of these cases, something that we want to push is the idea that we need to rethink processes. An example that people in robotics like to show is, for example, robots building up IKEA furniture. And this is something that is very challenging and not easy to do, but we question if this is really the right approach, to take something that was optimized for the human hand and then just do it with a robot. Maybe it's better to just 3D print it yourself, for example. Looking back into my background in architecture, we saw that initially people were drawing plans by hand. The first step in digitalization was not to draw by hand, but to draw on a PC. And then the next step was not just to draw things, but to algorithmically define that. And doing so was very important in order to consider aspects of fabrication and geometry at the same time as design. So it really allowed us to go to a different level. And this is something that we also wanted to explore in the fashion robotics project, not just to digitize fashion, but to think what changes if we go from 2D to 3D, from mass fabrication to individualization. We definitely didn't want to go that route of just having the robot sew by hand just now with a machine doing it. Instead, we wanted to investigate entirely new processes. One of these, for example, was electrospinning. It's a very exciting process where you spray a polymer into a high voltage field, and by going through the high voltage field, you create nanofibers, which can then be deposited on textile. So in this context, we used it to remanufacture and repair garments in a completely new and completely three-dimensional way. But it's not enough to just think about new processes. It's also important to consider how we can make those processes available, because going from 2D to 3D, going from something digital to physical is a big step. So in this case, for example, we used a collaborative robot, and not only as a production device, but actually as an input device. So you saw the person guiding the robot and defining where the individual parts should be fixed. This is a project that we showed at the Automatica, which is one of the world's largest robotics fairs for KUKA, a large German manufacturer of robots. And we had a very good feedback here, and it was interesting to see also increasingly people from the fashion industry at these events. So with this, I hope I was able to give you a quick insight into what we do in the robotics aspects. I want to thank you for your attention, and I want to hand back to you, Christiane.
So just a small note, my colleague Johannes Braumann could not be here today personally because he had his second child just a few days ago. So that's why he was here with the video. So just quickly to introduce myself, I'm Christiane Luible. I'm from the Department of Fashion and Technology at the University of Arts in Linz. Previously, I worked for MiraLab, a research institute in Geneva, working a lot on digital tools. And my scientific interest is since 25 years, it's around digital tools for fashion design. And always in the bigger realm in the last years, of course, in the realm of sustainability. Now you can go to next slide, please. So today we have a lot of digital tools available. I also saw that there are very interesting presentation of the companies who provide the simulation tools. And why is this so important? We have powerful tools which are very precise. Here you see pictures from a research project, and we superposed the real garments with the digital prototypes. And we compared the accuracy. And in fact, today, the tools are really accurate enough to base important prototyping processes, because in the end, we want a physical product. So if you want to use the digital tools for a physical object, they have to be precise enough. And now we can go to the next slide. And so we base really important design decisions on this. We do choose fabrics upon this precise tools, but we can also control the fit because the parameters are precise enough. And we can even do more interesting design decisions. For example, in this project, we controlled the elongation of the fabrics for sports movements. So we could also integrate somehow the sports movement in the pattern making. And why is this so important? Because the question is, if we think of robotic manufacturing, and in the last video really explained the importance of this automation, what we really need in the fashion industry. The robotics is based on the digital prototypes. And the question is always, how do we treat this? So where is the transition point? When do we go back to the physical world? And now the next slide, please. And if you look at the manufacturing, so we are really good today in the digital design processes, but the manufacturing, we do pretty much in the same way as we did it years ago. It's a different question for the knitting. Today we have very powerful knitting machines and a lot of automation. But if you look at sewing, we can do 2D sewing processes, and it's more for simple garments. So the next slide, please. And here I want to throw a little bit back to a very old research project to a bit explain the problems. This is a research project from 2005 to 2009. It's a European project, and it was a very large one with 23 million. And we have been 37 partners. And I did actually my PhD on that project. And one part of that project was the robotic sewing of a suit, of a Senya suit. So it was a really high quality suit. So you can imagine the challenge was really high. So first we needed the accurate simulation, and then we prepared this mold. We took the path from the robot out of this mold. And at that time, we did the grasping with this hanger. So you saw in the previous video, we are much advanced today, but still the sewing is very complex. If we want to sew in 3D, it's very difficult that you bring the garment in the right position. So as you all know, still until today, we are not able to sew a suit. And this is also because we try something what is very complex and very complex processes. So the next slide. When I met Johannes in Linz in 2015, when I started there, it was very interesting that he had this very different approach. So in the Leapfrog project, we really tried to copy what we do in the real world, in the physical world. We had this very complex garment, and we want to recreate this. And this is complex. But Johannes' approach, it's more that the process itself, it's a kind of design. So we have to look at really interesting alternatives. And here he showed the electrospinning. And now you can go on the next slide and the next one, because we saw the video already. Thank you. So what we do now in Linz, we do not look at the process of sewing the most complex garment like a coat or a suit, but we want to experiment with remanufacturing. And we also saw in the previous video the importance that we do something with existing garments. We have a lot of garment what we need to sort in a correct way, but not every garment has to go to a recycling process. There are shirts and maybe they have just a little bit of stain or they're a little bit broken. And here we can easily apply a robotic process to print on it or to make simple cut or to sew something together without going back to a very complex process. So in fact, we can learn from the much simpler remanufacturing processes and implement the robotic, and then also learn for the manufacturing of new garments. And if you go to the next slide, so our dream in Linz is to build up a kind of micro factory. And this microfactory should be local and robotic driven, where we can act and act with companies in a very flexible way for smaller productions, for repair, for remanufacturing, or for new series. But we have these little cells of robotic where we have the mannequin, and the robot is designed to execute processes. And often in remanufacturing, you cannot cut into a garment. But we can project the thing what we want to apply on a screen, and then the robot is executing it. So this is the longer term goal where we work on in research projects. And now if you go to the last slide, and here you see also a bit the work and the philosophy what we do in Linz. For us, it's important that we do not copy what we actually do in the physical world to really imitate the sewing processes, but to find new processes. So first, it's the remanufacturing, but here we also work on completely new ideas of making garments. On the left side, for example, you see a braided textile. It's done with a radial braiding machine, and compared to the knitting, here the robot is tearing the garment, and you have a garment in 17 seconds and not hours. So it's a huge advantage with regards to time. Or for example, the robot on the picture above is doing liquid printing. So he helps us also with some kind of 3D printing. And on the right, you see Michael Wieser, and they have the startup Yokai, and they do welding with the robot, because the welding is a simpler tool for the robot than to having a sewing head on the robot. So this is a bit what we do in Linz, to think of remanufacturing processes, to learn in simpler processes for the robots, for the robot movement, and also to think of completely new processes. Thank you for your attention.
Oh my God. Okay, I have to tell you first. The first time I went to Geneva to Miralab, it was like in,
You know Miralab?
1999.
Oh, really? I arrived in 2000, so we missed each other. Wow.
And you know, the stuff that was happening in Miralab was just incredible, right? I remember it was the first dancing robot that actually took the skeleton for the Davos project that actually came out.
I'm so glad you know Miralab. Great.
But what I love about the projects that you're doing is that there can be a standalone fixing location for people. For instance, you know, we see a lot of things sometimes that, you know, oh, how you can darn your socks. Listen, I'm not going to darn my own socks. I know this because I don't have that kind of time. But if I could bring it to your store, and there could be a retail concept where you take that and I can spend €5 and somebody can fix it for me because your robot can do it, and I can choose my thread that I do. What you're showing is fantastic. I'm so excited for this. And I have to put you in touch with HKRITA so you can take their sorting.
Absolutely. I absolutely believe in this. I think everything with this remanufacturing, it's today in this do-it-yourself community, but it doesn't have to be. If you do it with a robot and in this local micro factories, you can do this remanufacturing on a cost level, which is really interesting. And I think we need to automate these processes. Otherwise, it's not interesting for the industry.
We absolutely need to automate these processes because it's not only industry, it's also people, right? You know, we have to create this recrafting of that. We can bring technology so that young people they both also understand craft, right? It's kind of a merging of those two things. And because you're both professors, I mean, I know you see a lot of young people and what they find really interesting. And especially in Europe, one of the things that I realize is that you have access to machines and you have access to a lot of the things that sometimes people don't see. And it's so wonderful to see your that braiding machine.
Yeah. This was a collaboration with the TU Munich. They have this braiding machine and they had time. So I think this was a really interesting experiment. And now we are working on making the garment a little bit more elastic, that you can easier slip in. We already have a little upper part. And I really believe that these are new processes. We should not think in sewing suits. We should absolutely think of using the technology for creating and designing the processes. And the students are good in that, actually. We really have interesting projects going on. So
and it's a really new way of re-engineering, you know, the world. And so with that, I'm going to say to all of you retailers out there who want to have a remanufacture or sewing and cool kind of thing, you have to talk with University of Linz and also come and talk to HKRITA. You can use me and I will get you to the right people. And we thank you very much, Christiane, for showing us those very exciting machines. And with that, we are moving on to the next speaker.
thank you, Janice.